Hey everyone, and welcome back for another deep dive. You ready to explore some seriously fascinating research on coral reefs?
Always ready to dive in.
Okay, so today's deep dive is focused on a study y'all sent our way, and it's all about how these underwater cities are growing, or really not growing, as our oceans continue to change.
It is a pretty dense study.
Yeah.
It's definitely a scientific paper.
Yeah. This is not light beach reading material.
No.
But don't worry, that's what we're here for. This study looked at coral cores from across the Indo-Pacific. We're talking 148 cores, some of them dating back to the early 1800s.
Wow.
I know, right? That's a massive data set. That gives us a real window into how corals have been faring over time.
It does, and what they found is pretty alarming. Coral calcification, the process that allows corals to build their skeletons and create those amazing reef structures,
Yeah.
has been declining.
So it's like the building blocks of these underwater cities are getting weaker.
Exactly. And that has serious consequences.
Mm-hmm.
A declining calcification means slower reef growth, weaker structures, and reduced habitat for all the amazing creatures that call reefs home.
Yeah, it's like a domino effect.
Exactly, rippling through the entire ecosystem.
Okay, so the big picture isn't looking so great, but the study also found some interesting regional differences.
Right.
Yeah.
Absolutely. The declining calcification isn't happening uniformly. The Red Sea, for instance, is showing some of the most significant declines. It's warming at a rate nearly double the global average, and the corals there are feeling the heat literally.
Wow, so the Red Sea is kind of like a canary in the coal mine.
Yes,
It's given us a glimpse of what might happen in other areas as ocean temperatures continue to rise.
precisely. And that's why studies like this are so important. They help us identify the areas that are most vulnerable and prioritize conservation efforts where they're needed most.
Now, the study delved into how corals are growing differently. They looked at linear extension, which is how much they grow upwards, and skeletal density, which is how tightly packed their skeletons are. What did they find there?
Well, it turns out that linear extension is taking a bigger hit than density, which means the corals are growing slower overall.
Interesting.
And this actually challenges some previous thinking that focused primarily on ocean acidification's impact on density. It seems that warming waters are actually slowing down the growth process itself.
Oh, so it's not just that the building blocks are weaker, it's also that construction is slowing down.
Precisely. And that has long-term implications for the ability of reefs to recover from disturbances like storms or bleaching events. If they can't grow fast enough to keep up with erosion or damage, the reef structure itself is at risk.
Now, this is where things get even more complex. The study also found that coral growth naturally fluctuates over decades. They called these multi-decadal oscillations. So are we saying some of the recent declines could be part of a natural cycle?
Yes. It's not as simple as saying all the decline is due to climate change. These natural ups and downs are like a coral roller coaster, and some of what we're seeing could be part of that ride.
But those natural cycles are now happening against a backdrop of long-term warming, right? It's like the roller coaster is on a track that's slowly tilting upwards.
Exactly. And to make matters worse, we've had those super strong El Niño events recently. They seem to coincide with some of the worst years for coral growth. The heat stress from those events really takes a toll.
It's like the roller coaster suddenly hit a patch of scorching hot track.
A very apt analogy.
Yeah.
These El Niño events highlight the complex interplay of natural variability and human-caused climate change. We need to understand both to accurately predict how corals will fare in the future.
And speaking of predictions, the study revisited earlier work on the Great Barrier Reef. There was a lot of talk about the reef hitting a tipping point and being in serious decline, but this newer data paints a slightly different picture, doesn't it?
Yes. This research, with its longer timeline, suggests those earlier predictions might have caught the Great Barrier Reef during a downswing in its natural cycle. It's not necessarily on the brink of collapse, at least not in the location studied in this research.
So a little bit of good news there.
It's encouraging, but we can't get complacent. The long-term warming trend is still a major threat. It's like dodging a bullet, but you're still in the middle of a shootout.
Right, the danger is far from over. This study really emphasizes the importance of long-term monitoring. We need to track these changes over decades to get the full picture.
Absolutely. And this is just one piece of the puzzle. The study focused on Pomato corals, which are known to be quite resilient.
So the tough guys of the coral world.
Exactly. But what about all the other more delicate coral species? How are they coping with these changes? That's a question worth exploring further.
Yeah. That's one of the big takeaways from this study. It highlights just how complex these ecosystems are and how much more we need to learn. Like, they looked at human impact using something called the gravity metric, and found it didn't directly correlate with coral decline.
So does that mean like humans are off the hook?
Not so fast. It just means that particular metric wasn't a good predictor in this study.
Okay.
It doesn't mean human impacts aren't playing a role. We need to explore how those impacts might be affecting things, perhaps through factors like pollution or overfishing or coastal development.
Right. So the whodunit of coral decline is still a bit of a mystery, but with climate change as the prime suspect.
Precisely.
Yeah.
And just like a good detective, we need to look at all the evidence and consider multiple factors, and these can interact in really complex ways, making it even harder for corals to thrive.
Yeah, it's like trying to solve a puzzle where the pieces keep changing shape. A very apt analogy. And that complexity is why research like this is so crucial. It helps us understand the nuances of the problem and tailor our conservation strategies accordingly. We can't just treat all coral reefs the same. We need to consider the specific challenges facing each region.
So a one-size-fits-all approach won't work.
Exactly. This study, with its focus on regional differences, really drives that point home. It provides a more nuanced picture of how corals are responding to environmental change.
Now, we talked earlier about the tipping point idea for the Great Barrier Reef. While this study suggests it might not be doomed, does that mean we should just breathe a sigh of relief and move on?
Not at all. Remember, the long-term warming trend is still a major threat, and the Great Barrier Reef has already experienced significant bleaching events in recent years. This study might show some resilience in the specific corals and locations they studied, but that doesn't mean the danger is past.
So we've dodged a bullet, but we're still in a very dangerous situation.
Precisely. This study underscores the need for what's called adaptive management. We need to be flexible and adjust our strategies as we learn more.
So constantly reevaluating our approach.
Exactly. And that includes prioritizing actions that enhance coral resilience, like reducing pollution, managing fishing pressure, and protecting key habitats.
So it's not just about mitigating climate change, it's also about giving corals the best possible chance to survive in a changing world.
Exactly. It's a multi-pronged approach. Now, the study also touched on something I find really exciting, the use of new technologies to monitor coral growth. They specifically mentioned 3D photogrammetry.
Yeah, what is that exactly? Sounds pretty high-tech.
It is. Essentially, 3D photogrammetry lets us create detailed three-dimensional models of coral reefs using photographs. This allows researchers to track growth and changes in the reef structure over time.
So we can see how the reef is changing in 3D over time?
Yes, it's like having a time-lapse video, but with incredible detail and depth. And it's non-invasive, meaning we're not disturbing the corals themselves.
That's amazing. What kind of insights can we gain from this technology?
Well, it allows us to monitor a wider variety of coral species, not just the massive Porinites corals this study focused on. We can track growth patterns, identify areas of damage or recovery, and really get a comprehensive view of how the reef is responding to its environment.
It's like having a whole new set of eyes on the reef.
Exactly. And this technology is becoming increasingly accessible, which means more researchers can use it to study and protect these valuable ecosystems.
All this talk about technology and data is fascinating, but it's easy to forget that coral reefs are more than just data points.
You're absolutely right. They are vibrant, living ecosystems, teeming with life. We need to remember that we're trying to protect not just the corals themselves, but the entire interconnected web of life that depends on them.
It's about saving the heart of our oceans.
Beautifully put. And this research, as complex as it is, brings us closer to understand how to do just that.
Speaking of complexity, let's circle back to those multi-decadal oscillations in coral growth. Can those natural cycles offer any hope for reefs?
That's a great question. Some research suggests that during the upswing of those cycles, corals might be able to recover more quickly from disturbances like bleaching events.
So it's like when you're recovering from an injury, if you're in good shape overall, you tend to bounce back faster.
Exactly. And those periods of enhanced growth could be crucial for reefs to buy some time and adapt to the changing conditions.
So these natural cycles could act as a buffer against climate change.
Potentially, but it's important to remember we can't rely on them alone. We still need to address the root cause of the problem, which is climate change.
We can't just cross our fingers and hope for a good decade.
Right. It's not a magic solution.
Yeah.
However, understanding these cycles can help us time our conservation efforts more effectively. We might prioritize restoration efforts during those periods of naturally high coral growth.
It's like a gardener planting seeds when the conditions are most favorable for growth.
Exactly. And it highlights the importance of long-term monitoring and data collection. We need to track those cycles and understand how they vary across different regions.
It all comes back to data. But beyond all the science and statistics, there's something profoundly humbling about these coral reefs. These tiny animals building these vast, intricate structures over centuries, facing these incredible challenges.
You're right. They're a testament to the power of nature and the interconnectedness of life on Earth, and a powerful reminder of our responsibility to protect them.
Absolutely. Coral reefs are a global treasure.
They really are. And this research, as complex as it is, it brings us closer to understand how to do just that. Understanding these cycles can help us time our conservation efforts more effectively. Like we might prioritize restoration efforts during those periods of naturally high coral growth.
So it's a matter of working with nature's rhythms, not just trying to fight against the tide.
Exactly. And it all comes back to data. We need to track those cycles and understand how they vary across different regions.
Data is key, as always. But beyond all the science and statistics, there's something profoundly humbling about these coral reefs. These tiny animals building these vast, intricate structures over centuries, facing these incredible challenges.
You're right. There's a sense of awe and wonder that comes from studying coral reefs. They're a testament to the power of nature and the interconnectedness of life on Earth.
And a powerful reminder of our responsibility to protect them.
Absolutely. Coral reefs are a global treasure, and we need to do everything we can to ensure their survival for generations to come.
Well said. To our listeners, we hope this deep dive has given you a better understanding of the complexities of coral growth, the challenges they're facing, and the glimmers of hope that exist. Remember, even small actions can make a difference.
Yeah, supporting organizations that are working to protect coral reefs, reducing your carbon footprint, and spreading awareness about these incredible ecosystems can all contribute to their conservation.
And if this deep dive has sparked your curiosity, we encourage you to keep exploring. There's a wealth of information out there about coral reefs.
And if you come across any other fascinating research, send it our way. We'd love to do another deep dive with you.
Until next time, keep exploring, keep learning, and keep diving deep.